Vanakkam one and all. Here we will discuss problem number 29 of exercise 5.1. Here they have stated find the value of k so that the function f is continuous at the indicated point. The point is 5. So we'll see the domain of the function. The domain of the function is entire real line, because for all x less than or equal to 5 we have f of x as kx plus 1, and for all x greater than 5 we have f of x as 3x minus 5. So we are assuming the function is continuous at the given point 5. So when the function is continuous at given point, we have to say left hand limit equal to the right hand limit equal to the functional value at 5. Okay, so I have written like this. Now we will know the functional value f of 5. When the value of x is 5, we can take the function as kx plus 1. Here we will replace x as 5. So 5k plus 1. This is the functional value. Now we will calculate left hand limit. So when we take 5, it has right hand neighborhood and left hand neighborhood. In right hand neighborhood, elements will be 5 plus h, where h is a positive real number. And in left hand neighborhood, elements or numbers will be 5 minus h, where h is a small positive real number. Okay, so now we are calculating the left hand limit, which means the values of x are approaching 5 from left hand neighborhood. So limit, so in this case x values will be 5 minus h. Again, as x tends to 5, h tends to 0. Now limit x tends to 5 from left hand neighborhood. In the left hand neighborhood of 5 we have kx plus 1. The function as kx plus 1. So kx plus 1. So now we can rewrite it as limit h tends to 0 k 5 minus h plus 1. So this one can be written as limit h tends to 0 k 5 minus kh plus 1. After substituting the limit, we will end up with 5k plus 1. So this is left hand limit. So as we are considering the function is continuous at 5, we can equate either one of this limit, left or right hand limit, to the functional value. Okay, now we will calculate right hand limit, because this expression is independent of k. So once we apply the value of x over this expression, we will get some constant. So we will find right hand limit now. So in the right hand neighborhood, we will have 5 plus h. Again here, as x approaches 5 from right hand neighborhood, h value tends to 0. So limit x tends to 5 from right hand neighborhood, where the corresponding function is 3x minus 5. 3x minus 5. Now we will replace x as 5 plus h. So 3 into 5 plus h minus 5. So after substitute, okay, we will apply limit 15 plus 3h minus 5. After substituting limit, we will have 15 minus 5, 10. So 10 is right hand limit. As we are assuming the function is continuous at 5, we can equate this right hand limit with the functional value. Functional value is 5k plus 1. Now we will get, after transposing this to here, we will get 9, 5k. So k will be 9 by 5. Or we will divide the expression by 5. So we will get 9 by 5 as k. So the k value should be 9 by 5. So the function will be continuous. When the value of k is 9 by 5, the function will be continuous. Now we will discuss problem number 30. Here they are asking us to find the values of a and b such that the function defined like this. The function has been defined in segments is continuous. Okay, it's a continuous function. So we need to find the right values for a and b such that the function is continuous. Now we will know the domain of the function. When we assume the real line, we have 0 and goes up to infinity on right hand side and goes up to minus infinity on left hand side, and I represent few integers over that. Okay, now whenever the values of x less than or equal to 2, so in this portion for this domain the function will be f of x will be 5, which is a constant function, and when the values of x are in the interval 2 greater than 2 and less than 10, in this interval the function will be ax plus b. The domain is when the domain is 2 to 10, I mean open interval 2 to 10. In this the function will be ax plus b, and once the values are equal to 10 and greater than 10, the function will be 21. F of x will be 21. Again here it is a constant function. Now we have to assume the function is continuous, and we will, after assuming the function is continuous, we will be able to derive the values of a and b here. Now when we see that the domain for x less than 2, we have the function f of x as 5, which is a constant function. So anyways it will be continuous. Okay, once the domain value started reaching 2 and more than that, the function, when the values of x exceeds 2, we will have the function like this. So the function has been defined like this segment. Now we will check the continuity. We will assume the continuity with these limits, with these numbers in particular. Only then it is easy for us to calculate a and b value. Now let us assume the continuity at 2. To say the function is continuous at 2, left hand limit at 2, okay, and right hand limit equal to the functional value. Okay, similarly we have to consider the continuity at 10. Okay, now at first I am going to consider the continuity at 2 and also at 10. Left hand limit at 10, right hand limit equal to the functional value. Yes, now we will calculate the limits. Now we will calculate limit x tends to 2 from left hand neighborhood. In the left hand neighborhood the function is constant function which is independent of 5. Okay, so independent of x, so we will get 5 only. So I will write left hand limit as 5. Or in the right hand neighborhood we have x as 2 plus h, where h is a small positive real number. So in the right hand neighborhood of 2 we have the function ax plus b. Now here as x tends to 2, h tends to 0. So we will apply limit h tends to 0, a 2 plus h plus b. Now we will apply the limit. After applying the limit we will get 2a plus b, because this h vanishes. So we will have 2a plus b, which is right hand limit at 2. Now this functional value f of 2 is 5, which is a constant. Since we are assuming the function is continuous at 2, this right hand limit is equal to the functional value. So 2a plus b. So 2a plus b is equal to 5. I am taking this as equation 1. Now we will find the continuity. We will assume the continuity at 10. So at 10, left hand limit. So in the left hand neighborhood will be 10 minus h. Again where h is a small positive real number. So limit h tends to 0. When in the left hand neighborhood the function is ax plus b. Ax plus b. So in place of x we will replace 10 minus h plus b. B constant. See here again, as x tends to 10, h tends to 0. We'll apply this. Now after substituting the limit, this h vanishes. So we will have a10 plus b. Now this is equal to the functional value. So in the right hand limit, because once the values are greater than or equal to 10, the function will take its value as 21. So the value will be constant. Anyway, we will get the same right hand limit. Right hand limit as 21, and also the functional value will be 21. Yes, we will equate this left hand limit with the functional value. 10 plus b. We are taking this as equation 2. Now we got equation 1 and 2. I'll rewrite it. 2a plus b is equal to 5 and 10a plus b equal to 21. Now we will subtract this equation 1 from 2. So when we subtract, we have to change, while subtracting we have to change the signs. After changing, we will get minus 8a, b variable gets cancelled, and then we will get, so here it is 16, minus 16. So minus gets cancelled, so we will have 8a is equal to 16, a is equal to 16 by 8, which is 2. We got a value as 2. Now substitute this to either one of this equation. Let me substitute in equation 1. We will have 5 is equal to 2 into 2 plus b, which is 5 is equal to 4 plus b. So we are transposing 5 to that side, left hand side, we will get 1 equal to b. So the value of a is 2 and b equal to 1. So the values of a is equal to 2, b is equal to 1, such that the function is continuous.